Hey everyone, welcome to math class. As you can see, I am out and I'm going to be gone until Friday. So I will miss all of you very much, and I'm very excited to hear how awesome you've been this week and how hard you've worked. I am sorry that you'll be doing all of this learning without me, but I know you're going to do outstanding. So once you are ready, you should have this slide in your Notability file. And then you should have my video in a split screen so that you can watch what I'm doing, and then you can make notes on your file going back and forth. And whenever I say pause, please pause, do the work, and then we will continue. So if you need to pause, pause. Otherwise, we're going to move to the next slide. So remember last week when we were simplifying this mat on the page in front of you, we ended up with an answer that depended on what our value of x was. When we got all down to just the final things that we could remove zero pairs and remove balanced sets, we ended up on mat A with 3x, and we ended up on mat B with the value of 6. We knew that we didn't want that because we wanted to be able to say, oh, mat A is bigger, mat B is bigger, or possibly they're the same value. So we moved on and we had a discussion about what if x is 0? And what if it's 2? And what if it's 3? So just to remind you, as we were working on this, I did the following. For the first one, we said what if x was 0? And we said 3 times the value of 0. And then how does that compare to 6? Well, 3 times 0 is 0, and that's going to be less than 6. So if x is 0, then that means mat A was less than mat B. When we took a look at if the value of x was 2, again, we took 3 and we substituted the value of 2, remembering that parentheses mean multiplication. And we got 3 times 2, which is 6. And 6 is equal to 6. Excuse me. So if x is 6, then that means mat A would end up being equal to mat B. And then lastly, we said, well, what if x was 3? So if we have 3 and we substitute in the value of 3, we're still asking ourselves, how does that compare to 6? Well, 3 times 3 is 9, and 9 is greater than 6. So in this case, if x was the value of 3, mat A would end up being greater than mat B. So the question is, where does the change come from when you're looking at something less than all the way to greater than, and then the point where they are equal? So that's kind of what our lesson is going to be about today, is this idea of where things are equal and what happens on either side of the equality. So let's go to the next slide. So the point where this shift in value occurs, where the change happens, where something is no longer less than, greater than, or equal to, is called the boundary point. The boundary point. And that's what we're going to be talking about today, is something called the boundary point. Before we continue to move forward, it's important that we actually go back and have a little bit of a discussion about things that you might have learned back in elementary school. So we have discussed and we have talked about what it means with this symbol here and with this symbol here, greater than and less than. And of course, we've talked about our favorite equals to. But what we haven't talked about are the two additional types of inequalities that we can have. They are greater than and also equal, which is this one, and less than and also equal, which is that one. These symbols, what they mean is that the value is equal at a certain point as well as greater than or less than. So what do you notice about the difference in these two things? Well, it's very clear that the ones up here do not have a little line underneath the inequality, and these down here do. So I'm talking about this line right here. If you think about that being part of the actual equal sign, what we have is the inequality plus the equal, the inequality plus the equal. Whereas up here, we just have the inequalities, not the also equal. So by adding that line underneath, we mean also equal. So it's important that we understand that before we move forward. So understanding this idea of boundary point, when we use the boundary point, we're going to be using it on a number line. We're going to be making a circle at the point where the boundary point exists. We're going to either fill in our circle or not, depending on if the boundary point is also equal at that point. So that's the key, also equal. This is a really handy slide to have. Maybe you want to, at some point, take a screenshot of this, maybe pause the video right now and take a screenshot of this to help you remember what the inequalities look like. It's so easy to forget, especially since we have so much information right now running around in our brains. So pause this if you need to, take a picture, and then come back to me when you're ready. All right, let's continue. So these two up here, these mean also equal, and the circle is filled in. Remember, these lines down here are half of our equals sign. So this would be greater than an equal or less than an equal, depending on how you're looking at it. Now, the next ones down here, they do not mean equals to, right? Because there's no other line underneath. They just mean greater than or equal to. So because of the absence, the lack of any type of equal sign, our circle is not filled in. So when there is equality, we fill in the circle. When there is not equality, we do not. Lastly, when we take a look at our equals all in, it should stand to reason that when we are talking about something being equal, we would color in our circle. It's always filled in. So we have three types of circles, 1, 2, and 3, with circle 1 and circle 3 looking the same, but being the same for different meanings. So today, what are we going to do? Today, we are going to practice finding the boundary point of an inequality. We are going to practice placing the boundary point on a number line. We are going to practice correctly drawing the line that extends from the boundary point. And then, once we get that all done, we're going to practice writing the inequality. We're going to go backwards. So let's begin. Finding the boundary point of an inequality. The question is, what is the boundary point for the inequality that reads x is greater than 3? Well, the first thing we want to ask ourselves is the circle filled in or not? Why don't you pause this for a second and answer that question? Now that you're back, hopefully you said the circle is not filled in because there is no equals to right here. It's just greater than. So that means we're going to have an open circle. So let's draw that. The 3 is our boundary point. So we're going to go to the 3, and above the 3, we're going to draw a circle, and it's going to not be opened. I'm sorry, that was said totally wrong. It's going to not be closed, so it's not drawn in, excuse me. Now, do you see how our arrow is pointing to the right? That means that our line will follow the same direction and point to the right. And at the end of the line, we're going to draw an inequality or an arrow that looks exactly like the arrow that's there. They should be facing in the exact same direction. What this says is, for all values greater than 3, the inequality is true. I hope that that makes sense. We're going to do it again. Let's go to the next slide. Okay, what is the boundary point for the inequality? You can pause this and draw it yourself and then come back when you're ready. Is the circle filled in or not? Well, do you see that we have also equals to? So the circle is filled in. Yes. What is our boundary point? Our boundary point is -2. So we're going to go to -2 on our line. We're going to go right above it. We're going to draw ourselves a circle. We're going to fill this circle in because we have a value that is equals to as well as less than. So there we go. You can see that our arrow, if you take a good look at it, is going this direction, which means that our line is going to go this direction. And at the end is going to be an arrow that looks exactly like that one. That reads, x is less than and also equal to all values starting at -2 and going down. All right, let's keep going. Next slide, please. All right, here's another one. What is the boundary point for the inequality? Again, if you want to give it a try, pause the video. See if you can do this one without my help, and then come on back when you're ready. So is the circle filled in or not? Well, the answer to that is no, it is not. There is no equals. What is our boundary point? Well, our boundary point is 1. So let's go to 1 on our number line, which is right here. We're going to draw ourselves a circle right above it, but we're not going to fill it in. And just like before, we're going to go this way with our arrow because that matches our inequality. So our line is going to head away, and at the end, we're going to draw an arrow that one more time looks exactly like the inequality. I hope this is starting to make sense. Let's try another one. What is the boundary point for the inequality? X is greater than and also equal to the value of 0. Again, pause it if you think you might know, and then come back to us and check your answer. Is the circle filled in or not? It is absolutely filled in. Yes, because we have this also equal to. What is our boundary point here? Well, it's 0, and 0 can be a boundary point. It's on the number line. If you look above you in my classroom, you can see 0's right there. So we're going to come down to 0. We're going to circle. We're going to color in because we also have equals to right above that 0. And then what are we going to do? Well, our arrow goes that way. So our line is going to go that way. And we're going to have an arrow at the end of it. And there we go. X is greater than and also equal to all values beginning at 0. How did you do? I hope you did great. Let's take 1 second to review. Okay, what have we learned about so far today? Well, we've learned about inequalities. We now have 4 of them. If you include the equals, it's 5. We have less than or greater than. We have less than or equals to, greater than or equals to, and we have equals. When we talk about our boundary points, when we have less than or equals to, we have an open circle, not filled in. When we talk about less than or equals to, or greater than or equals to, we end up having a circle that would be filled in because we have values that exist at that point, at the boundary point. And then lastly, we have equals, which again is a filled in circle because that circle represents equality at that actual number on our number line. Well done. Let's continue. All right. It's always important to go backwards, right? That's what I tell you. If you can understand going backwards, then you know you've got it. So let's give it a try and see where you're at in your learning curve. We're going to do that by trying to write the inequality for this situation. So we already have a number line, we already have a circle, and we already have a line with an arrow at the end of it. So we need to fill in all of the things that make the inequality. So let's start with the boundary point. What is the boundary point? Well, where is our number and where is the circle above that number? Okay, well that is right here. It's 1. So we're going to keep x on the left. We're going to write our boundary point on the right. So x goes on the left, 1 goes on the right. Is the circle filled in or not? It is not. So then there is no equal sign. And then there's our little trick, right? We have an arrow that looks like this. So that's what our inequality looks like. Exactly the same, just like when you were drawing it in the problems above. There's no line underneath because the circle is not filled in. X is less than, but not equal to 1. Let's try another. All right, what is the inequality for this situation? Well, we're going to start with our boundary point. Our boundary point is 2. Remember, we put x on the left. We put 2, our boundary point, on the right. We have an arrow, so we're going to do that. But what's happening right here with our circle? It's filled in. When it's filled in, that also means equality. So we need to add a little line underneath. X is less than and equal to all values starting at 2. Excellent. Let's move on. All right, 2 more. The top one. What is our boundary point? Well, it's 13. So x goes on the left and 13 goes on the right. Here's our arrow. So we're going to draw that. And do we have a filled in circle? You bet we do. So it's also equal. Next one. What's our boundary point here? Well, it's -5. So -5 goes on the right. X goes on the left. Here's our arrow. Do we have a filled in circle? We do not. So there's no equal. So that's it. We're done. What did you think? Did that make sense? I hope it did. So I'm really proud of you today. This is a lot to take in, especially with me not being there. So well done. I wish I was at school with you to see how you rocked this lesson and to answer any questions that you might need. But you're going to practice all of your skills from today in the R&P that's listed in Canvas. We're going to do a change to R&P this week. I'm going to give you a little bit of R&P that's going to be a lot of problems just to practice, and they're due that day. So it's kind of like classwork since I'm not there to keep you busy. So back in your modules, there's a worksheet that's called Monday 228 R&P. Once you complete this lesson and you're ready, complete the entire thing and submit it to Canvas today. It is due today. The key is also located in the module if you want to check your work as you go along to make sure that you have understanding. And I'll be back tomorrow with some more fun learning and can't wait to see you guys again on Friday.